Okay, thanks very much. Thanks, everyone. So talk is called Domain Modeling Made Functional. And my name is Scott Wlaschin, and that's my Twitter handle, if you ever need to find me. And I have a website all about F# called F# for Fun and Profit. I will be using F# in this talk, but the topic is really about, it's not specifically about F#, it's about domain modeling in any kind of functional language. So hopefully it'll be useful for using TypeScript, you're using even Scala, even maybe a bit of Kotlin. There's a lot of these techniques will apply to any language. So functional programming, most people think is only good for mathematical things. I think it's a very mathematical thing, and I'm here to tell you that that's not true. I think actually functional programming is excellent for collaboration, for interactive stuff, for domain modeling, and in particular for representing a domain model accurately. So that's what we're going to talk about today. How can you represent a domain model in code accurately? So again, here's functional programming on one side, domain-driven design, which is typically very object-oriented, but I think that functional programming and domain-driven design have a lot of overlap, and you can use them. They fit together very nicely. So let's start off with design. Before we even start talking about coding, what about design? So just like any process, software development process has an input and an output. And there's a process in the middle where you do stuff, right? And we love to talk about the middle bit. We love to talk about the coding and the testing and our favorite programming language and our favorite editor and hardware and all these things. We love to talk about this as programmers, right? But you've probably heard of this expression, garbage in, garbage out. If you have a bad input, you will have a bad output. Even if you have the best programming language in the world and you have the best testing in the world and the best text editor in the world, you'll still have a bad output if you have bad input. So how can you reduce the garbage coming in, right? If you can reduce the garbage coming in, you will have a better output, a better chance of success, right? So that is what I am calling design. And you could also call it thinking before you start coding. We often just like to start typing and start coding. It's like think, talk to people, communicate with people, think about what you're doing before you do it, okay? The input to the process, the requirements, the design. So that's what I'm going to be talking about today. How can we do that? So I'm going to steal ideas from two areas. First of all, from Agile, and secondly, from domain-driven design, DDD. So from Agile, I'm going to take the idea of rapid feedback. So Agile is all about getting something out there, getting feedback on it as fast as possible, right? Don't wait 6 months to get feedback in a few days, right? Now, from domain-driven design, I'm going to take the idea of having this shared mental model that everybody should be using the same words, the same concepts, the same ideas. And if you're not using the same words and same concepts, chances are the project's not going to be successful. And these concepts are also represented in the code. That's the key thing. So here's a kind of a diagram of all this. We have our shared mental model. We have the developers. We have the product team. We have, domain experts. We have testers, all these people. And we also have this common language, right? The concepts and language are shared. But as I said, if you don't have a shared mental model, I do think the project's quite likely to fail. Now, how do you represent this in the code? If you can actually represent this model in the code, you have a good chance of acting as documentation. So if a new developer comes onto the team, they look at the code and you're using the same words and concepts in the code, that developer will get up to speed very quickly. And if they're talking to non-developers, they're talking to the domain experts or the product managers, whatever, by using the same words, that developer will then be productive straight away. So having it in the code is a really, really important idea. So the common language is in the code, not just in people's heads. So at this point, people say, can you really make the code represent the domain, right? Because this is what code looks like. We all know this is what source code looks like, right? It's what non-developers think the source code looks like, and maybe some C developers think this as well. But, I'm not going to talk, this is not the kind of source code I'm talking about. The kind of source code I'm talking about looks like this. So this is F# code, and I want you to try and guess what domain I'm talking about here, right? So am I talking about, movies, or am I talking about, whatever. No, it's obviously I'm talking about a card game, right? You can see the words I'm using is everything to do with the card game. So these words down the side, this is the shared language that we're using in this particular domain. And so, I can actually explain this even to a non-programmer. I think this is pretty easy to explain. I can say this vertical bar, that means a choice. So a club or diamond or spade or heart. This star means a pair. So a card is you pick a suit and you pick a rank, and that is your card. We have lists built in, and we have these things with arrows. Now, arrows here, I am going to use this to represent a workflow, an action, a story, a use case, a scenario, whatever you want to call it, but some sort of activity, right? A verb, not just a noun. So let me just dive into this a little more, and I'll show you what I'm talking about. So let's say I want to model dealing a card from a deck, okay? So what is the input? Well, the input is the deck of cards, and after I've dealt a card, what's left is now a card. The deck is now missing a card, and there's now a card on the table. So there's two outputs. And because this is functional programming, we are not going to alter the original deck. We're going to make a clone of it with that card missing. So the original deck is not changed, it's not mutated, it's a copy, right? So the input is the original deck and the output are these two things. Now in F#, we could document it like this. We say the input is a deck and the output is a pair of things. And then there's an arrow between them. So this is the input and the output. Let's look at picking up a card. How do we model that? Well, when I pick up a card, I have some cards in my hand and there's a card on the table. So that's the two inputs. There's two inputs. And then I pick up the card and now I put it in my hand and now I have a new hand. So again, there's two inputs and one output. And again, I don't modify the hand. I just create a copy of it with this new card in it. So again, in F#, I would model it like this. The input is two things, the hand and the card, and the output is now my updated hand. So that's how you can model actions, use cases, stories, whatever you want to call them. But activities, you can model them just like you can model data. So it's not just data you can model. Now, here's a question. Do you think this is a reasonable amount of code to write to capture this domain? And I think, yes, it basically all fits on one page, which is really nice. Now, you're not looking in 20 different files. It's literally one screen. So that's nice. Do you think a non-programmer could understand this? And I can tell you for a fact that they can, because I have worked with non-programmers doing this kind of design, obviously not a card game, but taxes and more complicated things. And they can actually look at this and they say, yeah, this is great. In fact, someone said, this is excellent documentation. Where's the code? Because they didn't think this was code. They thought this was just some fancy kind of documentation. But this is compilable F# code. Do you think non-programmers can actually provide useful feedback? And this is the whole point of doing this, right? Is to get feedback, not just to show it to people, but to learn and learn what you did wrong. And there's actually a deliberate mistake in this one. And I don't know if anyone can see what the deliberate mistake is, but this is the kind of thing that if you were an expert in playing cards, you would notice this straight away. Even if you don't have to be a programmer, you just have to be an expert in card games. And I think, a lot of you are expert in card games, you'll probably notice that the ace is what's missing there. So that's the kind of feedback you can get. And again, when I've done it in real sessions, I've been documenting stuff and an expert will say, no, you forgot to do this and it doesn't work like this and you need this extra bit of input. And, that's very valuable information. And as I document this, I'm learning things all the time. So this is this idea of rapid feedback. And I really can't emphasize this enough because, if agile is great because you try and you do a prototype or you get something that you deploy very quickly, get some feedback very quickly, but even that takes days. And I'm talking about getting feedback in minutes, right? So let me give you a simple example of the kind of feedback that I would get, when I'm doing this kind of thing. So I often do a session and I have, I'm doing stuff on the whiteboard and there's developers in there, but there's also domain experts, there's also testers, there's also product owners and all this. Everybody's in the room, right? Everybody who cares is in the room. It's an interactive process and it's about building this shared mental model, right? We're all doing it together. And this is a great way for everyone to learn what the concepts are. So I'm going along, let's say I'm doing a card game or something, and I write down that a deal is what I said, you start with a deck and you have a new deck at the end and so on. Now, a domain expert might look at that and say, actually, that's not right. When we deal from a card, we actually use a shuffle deck. Okay, so I say, okay. So a shuffle deck is the input and the output is also a shuffle deck. Is that right? And they say, yes, that's just right. Okay. But now, if I'm not an expert, I would say, well, okay, so what is a shuffled deck, right? What is a shuffled deck? And they say, well, it's just a list of cards. So I say a shuffled deck is a list of cards. Now, what I don't do is say it's the same as a normal deck, but maybe with a Boolean flag, or it inherits from a base class or something, because they are different concepts. They might be represented by the same thing. They're both a list of cards, but an unshuffled deck and a shuffled deck are very different conceptually. You mustn't mix them up in a game of cards, right? Very important to keep them separate. So they're separate concepts. So they have the same representation, but they are different concepts in the domain. So I'm going to model it as a different concept altogether. And then because I'm a programmer, I want to know, where's the constructor? How do I make one of these things, right? So the expert will say, well, you just shuffle a deck. That is obvious to them. It's not obvious to me because I'm not an expert. So I write it down like this. To shuffle, you start with a normal deck and your output is now a shuffle deck. And I double check and they say, yeah, okay, that's good. Okay, so now I've learned something about the domain in a few minutes that I didn't really think about before. And if I'd programmed without shuffled decks, that would have been a bad bug. But by getting the feedback from the expert as early as possible, I've avoided a design mistake. So this happens very fast, very interactively, and there's no code written, although this is compilable code, but it's not like implementation code. So the final version looks like this, and we've now got this shuffle deck at the bottom, and the shuffle, we didn't have that before. Now, notice this is domain-driven design. This is not database-driven design. There's no tables, there's no foreign keys. The domain-driven design, people call this persistence ignorance, means you do not care how stuff gets into a database or is persisted. Now, at some point when you're writing the code, with the implementation, you are going to care about that. That's true, but it's not part of the design. The design doesn't care about that. And one way you can tell is if you didn't have a computer, if it was just paper and pencil, this would still be a good design. So it's independent of, it's independent of the way you implement it. So it's okay. Now the other thing is it's not OO driven, but there's no base classes, there's no manager classes, there's no factories. So there's, like I say, we don't inherit from a base class for decks and stuff. It's not object oriented. It's purely everything is a concept here. Now, so in the real world, we have concepts like a suit and a rank and a card and all this stuff. And in the code, we also have the same concepts, right? We want to match the code concepts with the real world concepts. And it has to stay in sync. So if you learn something in the real world, like this concept of a shuffle deck, you want to have that same concept in your code, right? So we change as we learn things, we change the code to have these new things in it. So that's good. That's the way it should happen. What you don't want to do is the other way around. What you don't want to do is say, oh, I have some programmer jargon. I have a player controller to manage the players, or I have a base class to manage the decks, or I have an abstract card proxy factory bean or something. Right? These things are programmer jargon. They should not be reflected in your code because they're not part of the code. The domain expert would not know what these things are. Now, again, in the implementation side of things, these things might be important, but in the design side of things, they should not contaminate the design. So unfortunately, I see a lot of people with their designs contaminated by the database tables or by various frameworks. Your framework, a framework often contaminates your design by forcing you to design in a certain way to make the framework happy. I personally think that's a bad idea. Okay, now, so this is the thing, the design is the code is the design. So this is compilable code. This is not just documentation, right? And what's nice about this is because it's compilable code, you can actually make this kind of drive the rest of the implementation. Think of this as a giant interface for the rest of the code. So typically in F#, this would be like your first file, and all the other implementation stuff would depend on this file. So if you change this file, the rest of the code, the implementation will have to change. And also, if you learn something during the implementation, you go back and you change this file to make it match. So the code and the design are always in sync, or the implementation and the design are always synced together, which is not true if you're using like UML diagrams or something like that. Okay, so this is executable code. It belongs as part of the application. It's not a separate file. Okay, so again, this process is not about just having a result like this, it's about building the shared mental model. It's all about collaboration. You're learning things. It's all about learning. It's not about it's not really just about documenting stuff. It's about the learning process of understanding all this stuff. So the shared mental model, this is a key thing about domain-driven design. Okay. Collaboration. Right. Okay. So that's the first part. So if there's one single way to summarize this, I would say communicate the design in the code. That would just sum up this whole thing, right? So here's a little challenge for you. I'm going to show you some code and you tell me, does it communicate the design, right? So this is a very simple contact. There's a name, first name, middle initial, last name, an email address. There's a Boolean flag, which is set to be true if you have proved that you own that email, right? You get an email and you click the link to prove that you own that email address, right? So that's a Boolean. And is the design very good, right? Is the design, there's a lot of issues, is the design communicated in this code? So the first thing I want to say is, well, is everything required or is something optional? So that's not documented here. So maybe say the middle initial should be optional, right? This is this is very American style name here, but okay. So in America, you know, people have middle initials, and other places they don't have middle initials. Now you could say, well, I'll just make the string blank or I'll make the string null, but that doesn't really document that this is optional and the other ones are required. Now, what are the constraints, right? So the first name is a string. Now, could it really be 1 million characters long? You know, what is the upper bound for a string? 64K? I don't know, but it's big. Now, typically, you know, a name should be, if it's going to be put in a database, it probably shouldn't be more than like 50 characters. Even if it's not in a database, it still needs to be printed out on a piece of paper at some point, right? So chances are there's some sort of constraint. Similarly, email address has a constraint. It can't be infinite long and it has to have an @ sign and all sorts of stuff, right? Now, the domain logic, this Boolean, when should it be true? When should it be false? Right? It's just a Boolean. So right now you'd say, well, I just look in the documentation, right? And the documentation says, well, if you change your email address, you have to set it back to false until you've verified it again. But that's in the documentation. How can I actually put that in the code, right? I don't want people to forget to read the documentation. I want people to be forced. I want people forced to set it to false. How can I force people to set it to false when the email address is changed? In the design, not in the implementation, but in the design. So this code does not communicate important design decisions. That's a big problem with it. Okay. So these things, what's optional, what are the constraints, all this stuff, I'm actually going to show you how you can fix all of these issues in this code. So, and this is with the functional domain modeling. Right. So before I do that, just one quick thing on functional programming and type systems. So the type system in the functional languages like F# or Haskell or OCaml or whatever is very different from a classic OO class model. And it's just very different. And that's one of the advantages that you can use for functional domain modeling. So in functional programming in general, the most important thing in functional programming is to use composition everywhere, right? So composition is like Lego. You start with small things and you connect them together and you make big things. That's composition. And functional programmers use composition, everything. They compose functions and they compose everything they can. And we're going to compose types, right? So building big things from small things is what functional programming is all about. So, okay. So in functional programming languages, there's something called an algebraic type system. Now, algebraic is a bit of a jargon mathematical word. So I like to use the word composable because it's a composable type system. You can build bigger types from smaller types using the Lego analogy, right? So there's actually two ways of doing it. One is to use the word and the other is to use the word or. So that's pretty simple, pretty easy. Let's have a look at what I'm talking about here. So let's say I want to model a fruit salad. And I say, well, a fruit salad is an apple and a banana and a cherry, right? So I'm using the word and, okay? And in F# I would write it like this. And notice this kind of looks like JSON, right? It's basically a record. And there's 3 fields. There's an apple field and a banana field and a cherry field. And the type is the second part. So what kind of apple is it? Well, it's one of the apple varieties, you know, a Golden Delicious or a Granny Smith or whatever, right? So that's how you do it in F# to do an and. Now, every programming language has things like this, whether you call them structs, records, even tuples or tuples. It's all different ways of having and. So this is not unusual at all. Now, the other way of doing it is using or. And this is a bit more unusual. And what we're going to do here is model a choice between things using or. So if I want to model a snack, I would say it's an apple or a banana or a cherry, right? One of them, but not all at the same time. So in F#, I would do it like this. I use the vertical bar. A snack is an apple or a banana or a cherry. So the vertical bar means or. And I call these choice types. The technical word is a sum type, or it's in F# discriminated union. So different words for these things. I like to call them choice types for modeling because they're a choice, right? So that's how you model choices. So you've got and or. So unfortunately, this kind of choice type is not really available in non-functional programming languages. You could think of it kind of like an enum with extra data attached to it. You could also think of it as maybe 3 different subclasses. It's not exactly either of those, but that's one way of thinking about it. If it's 3 different subclasses, they're all on 4 lines, which is kind of nice. So that's a kind of simple example. Let's look at a real world example if I want to model something more complicated. So let's say I want to model a payment system and I take cash, PayPal, or credit card, right? Now for cash, I don't need any information. For PayPal, I need some sort of email address. For cards, I need a card type and a card number and an expiration date and a code and all this stuff, right? So how would you implement this? How would you implement this requirement? Now, if you're an object-oriented person, you'd probably start with some sort of abstract base class or an interface or something like this, and then make maybe subclasses for each one, right? So here's an interface, right? Or you could use an abstract base class again, and then you create a subclass of that or an implementation of that, one for cash, one for PayPal, and one for cards. And each of the subclasses has its data that it needs. The PayPal has an email field that it needs for that, right? And that's the kind of OO way of doing it. But let's look at the compositional way, the building up from small pieces, the Lego way of doing this. So the Lego way is you start off with small pieces. So I'm going to start with an email address and a card number. And one thing is it's really important to use the words that experts use. People who do payments, they don't talk about strings, they talk about email addresses, they talk about card numbers, right? So we're going to model those concepts straight away. Right, so we're not going to use primitive types. We're going to use types that represent concepts, and then we can have a choice. So a card type is a Visa or a MasterCard or whatever, and the card information is a card type and a card number. So I've got a choice type here using or, and a record type using and then I can do my payment method. So I can say a payment method is a choice, something or something, cash or PayPal or card. And in the PayPal case, I have the email address, that's the extra information. And in the card case, I have the card info, which is extra information. So I've now modeled the 3 choices, in 4 lines of code. So that's very nice. So, and I don't have to stop because it's composition, I can build and build and build on top of this. So let's do some more. Let me talk about something called a payment amount, which is maybe a decimal or money type, okay? And then a currency is euros or dollars, right? So a primitive, a choice type, I keep going. So a payment maybe is an amount and a currency and a payment method. So now I have a payment that I can use. And again, I can build on top of this as well. So these ands and these ors, you can actually build really complex systems building from the bottom up in a nice way. So this final thing is built from lots of smaller types. And this is composition. This is how you do composition. And I think this is a really great way of building domain models. So that if you like Lego, you will like this. Okay, so now let's actually look at how you might do some of these things. So let's apply this to the contact challenge we just did, and let's see if we can fix it. So the first thing we have here is we have this very simple data structure with strings and ints and bools and whatever. This looks awfully like a database table. This looks like database-driven design, which is fine. And when you put it in a database, you might want to have a look like this, but this is not domain-driven design. This is database-driven design. So let's turn it into domain-driven design, okay? So the first thing is we would say a contact has a name and an email. We wouldn't say it has a first name and so on. So the contact is a name and an email. That's how we would actually describe it, right? And, okay? So I double check with the expert. They say, yeah, that's how we talk about it, okay? So we've already got some new concepts that we didn't have a minute ago. Personal name and email. Okay, now, what's in a personal name? So they say, well, it's a first name and a middle initial and a last name. Okay, so that's similar to what we had before. Okay, and then I say, well, what's required and what's optional? And it turns out the middle one is optional and the others are required. And that is not obvious at all from this code. So let's fix that. How do we represent optional values in the design? Now, optional values is a really important topic. And to show you why something like null does not work and why null is not the same as optional, let me just give you a little example. Let's say you're just having length of string, very simple function to calculate the length of string. So the input is any possible string, right? The set of all strings. We call the set of all strings type string. And the output is an integer, positive integer, so we call that int, right? So those are the inputs and the outputs, and we say string, arrow, int. But in most languages, null is a valid string, right? If you have a type string and you say, are you going to assign null to it? They say, yeah, that's fine. And the problem with that is that, null isn't a string. When you actually try and use it, so null really should not be in the list of valid strings. And it's just a historical accident that null is allowed. And in most functional programming languages, null is not allowed as a valid value for things, okay? So in F#, for example, you can't have a null contact, you can't have a null person, and so on. So don't allow null as a value, right? So if you don't allow null as a value, how can you represent something which is missing? How do you represent missing data? Well, you represent it as a choice, right? It's either a valid string or it's missing, or it's a choice. So I have a set of valid values and I have a set of non-valid values. There's only one is missing. So I'm going to model this with a choice type. So the first one I'm going to call something, and the second one I'm going to call nothing. So in F#, you'd write it like this. It's an optional string, and it's either something or it's nothing. Now, if it's something, I need to know what is the actual string that it actually is. So I need some data in that case. But in the second case, when it's nothing, I don't need any data. So there's my optional string. This is a much better model than using null. Okay, but then you might say I need an optional int, and I need an optional boolean, and I need an optional person, and an optional this, right? So yeah, there's a lot of duplication here, and you can actually get rid of all this duplication in one go by using generics. So in F#, we'd probably use this. Now, this is built into F#, but if it wasn't built in, it's 3 lines of code. Right, so this is a generic version, and you could have an optional int, an optional string, optional anything, because this little t means it's a generic type. So it will work with anything could be optional. So that's how you define optional types in F#. So we've got something, some data, or nothing. So again, it's the choice between something or nothing, and I'm using the word or. Right, so a choice type. So what I can do going back to my design, I can say this is an optional string. And now this is documented. This is better than before because it's not null. It's explicitly saying this might be missing. And actually in F#, you can actually put the option afterwards, which kind of looks a bit nicer to someone who's not a programmer. But basically they're the same thing. But either way, you're indicating in your code, this is an optional piece of data. So that's much better. Now, let's look at simple values and constrained values. It's really important when you're doing domain modeling to avoid what's called primitive obsession, right? So a primitive is something like an int or a string or a float or a boolean, if you right. Try and avoid them because they are not concepts in the domain, right? And I was once talking to somebody and I used the word float. I said, we should model this as a float. And they were like, they weren't a programmer. They said, is that something to do with water, right? I mean, and why not? It's a good question. So yeah, don't use the word float. Use the word money or use the word amount or use the word, whatever is relevant to the domain. So, and on top of that, even if you do have a primitive type like a string or an int, it's really unusual that they are completely unconstrained, that you have a string which can be 1 billion characters, or you have an int that can go up to, very large numbers or very large negative numbers, right? Really unusual. So an email address, it's not a string. It has to be, there's rules, right? It can't be empty. It has to have some sort of pattern. A phone number is not just a list of numbers, it has to be non-empty. It has to have some pattern. So there's always rules about these things. They can't be infinitely long. Almost always there's some sort of rules about what can be in these things. Even something like a customer ID from a database has to be a positive integer. It can't just be any old number. And another reason to model them separately is they are not actually strings. So email address is actually not a string. And a customer ID is not an int, right? How can I persuade you? Well, if it was a string, I could concatenate 2 of them and get another string. But if I take two email addresses and I concatenate them, I don't get another email address. It's not valid. So they're not strings. A custom ID, can I multiply it by something? Can I take the square root of a custom ID? It's not a number. It's not an integer. It's represented by an integer, but it isn't in fact an integer. I can't add one to it. I can't divide by a number. They're not numbers. They're represented by numbers, but they are not numbers. So you do not want to mix them up with ints and strings, right? So in F# and in any language really, you want to create wrapper types to keep them separate. So in F# I would do this. This is a wrapper type around a string. It's a wrapper type around an int, right? So these are no longer ints and strings. They are wrapper types. So that's really important. And even something like a string 50, like say have some sort of constraint, it has to be a 50 character string. I'm going to use a wrapper type. I'm not just going to have a plain old string. Okay, so here we have two different wrapper types, and because of that, they are not, you can't mix them up. The compiler will not let you mix them up. Here's two other distinct types. This is a very common problem. Sometimes if you're using ints, you might get the wrong order in the parameter list or something, and that would be a bug, right? If they are separate types, the compiler will not let you mix them up. So what's great about this is better domain modeling, because you now have these concepts in your code documented, but also it prevents certain kinds of bugs. You can't accidentally mix them up. So you never mix up an email and a phone number this way. So it reduces bugs, and it's also better documentation. So win-win. Now, how do we actually implement, a constructor for these things, right? So let's say I want to create an email address. What I would say is doesn't contain @sign. And if it does contain @sign, then wrap up the email, wrap up the string. If it doesn't contain @sign, well, that's an error. What am I going to do? I'm not going to return a null. I'm not going to throw an exception, because if you look at the signature, if you look at the inputs and outputs, if it looks like this, you give me a string and I'll give you back an email address as the output. That's actually a lie, because some of the strings I give you are not valid email addresses, right? So this is actually, if you ever see something like this, this is a lie. This is going to fail at runtime. So what I'm going to do instead is use options. Like if you give me a valid email address, I'll give you back something. And if you don't give me a valid email address, I'll give you back nothing, right? So I'm going to use an optional type. And again, if I look at the signature, it says you give me a string and I might give you back an email address. That's much better. So it's much better documentation and less things to go wrong. And same thing with a constrained string like a string 50, right? If it's less than 50, it's good. And if it's not, it's bad. So again, I can, just by looking at the signature, I can say that sometimes it might not work. And that's nice documentation for me as a user. It's not going to, I know it's not going to throw an exception, right? I don't have to look at the documentation to see, does it throw an exception? It's like, I can tell straight away that it might not work. Here's another example. This is a real example I saw once where you could actually have like 1 million items on your e-commerce site, right? And that's probably a bug, because you really can't have 1 million items. Most Amazon will not let you buy 1 million things, right? The reason that happened was probably because they were using an int behind the scenes as their model, right? And that's a danger, because you could have very large numbers, you could have negative numbers. So you really shouldn't be using an int to model this kind of stuff. So what you should use instead of an int, we're going to have a special wrapper type, right? A special wrapper type just for this domain. Right now, this isn't a lot of extra work, but if it's just one line of code, it's not bad. If it's like, if you have to do 20 lines of code, a lot of people wouldn't bother. But if it's one line of code, you're much more likely to do it. So pick a language where doing this kind of thing is easy, because you want to do it lots and lots. So again, the constructor would say, if it's bigger than 0 and less than 100 or whatever, then it's valid. Otherwise, it's not valid. And if I look at the signature, it says you give me an integer and I might give you back a valid quantity. And what's interesting about this is that 0 is not a valid number. So if you hit the minus button on your Xing and it goes down to 0, you cannot get one of these things. So you are forced to deal with it in your code. What happens when there's 0? You can't accidentally forget about it. You have to do something like remove it from the shopping cart, or but what you can't do is ignore it, because the code will not compile if you ignore it. And this is great, because you don't have to have a unit test for the case where it's 0. You don't have to have documentation for the case where it's 0. You literally cannot write code where it is 0. It just cannot happen. So I highly recommend you do this kind of thing. So let's revisit the challenge now after the first refactoring. So we have an option now, right? we have these constrained types now, which is much better. And we split it into two pieces, two different domain concepts. And these domain concepts are actually also very good for consistency boundaries. Like if I have two people editing something, if two people edit the name at the same time, that's a bug. I have a concurrency issue. If one person edits the name and somebody else edits the email at the same time, that's not a bug. So these act as boundaries for integrity as well. Now, the last thing we have to talk about is this Boolean, right? And we're not going to use Booleans. We're going to replace Booleans with choices. So here is our Boolean. Is the email verified, right? So what is the logic around this? And I said we want to try and avoid users having to, programmers having to look up documentation. I want to put it in the design. So can I do that? Okay, so the rule is if you change the email to an unverified address, you have to set it to false. And also, if you want to set it to true, it has to be verified. It has to have gone through the verification service in order to be verified. Right, that's very important. We don't want to just set it to true because you might have a security risk, like if I send password resets or something. So how do we force these rules to happen? Because right now, anyone can set it to true, and that would be a bug. So let's see what the domain expert says. I would say to them, they will tell me an email address is either verified or unverified. Okay, so I'm going to model it as a choice, right? It's either verified or it's either unverified or it's verified, right? Now, if it's unverified, it's just a regular old email address. That's fine, because I can use any old email address. Now, what about if it's verified, right? So that's fine. Any old email address to do, but if it's not verified, what am I going to do? Well, I'm going to go back and ask the domain expert, and I say, is there a difference between a verified email and an unverified email? Are there different business rules around them? And they would say, yes, you don't want to mix them up, just like the shuffled deck of cards and the unshuffled deck. Really important that you don't mix them up. So, okay, how am I going to not mix them up? I'm going to create a wrapper type, right? So this time I'm wrapping a regular email with this new thing called a verified email. So I've got a wrapper around a wrapper. And there's no problem that can't be solved by wrapping something in another type. So I've got my verified email. Okay, now the next question is, where do I get these verified email things from, right? I'm going to ask the expert, and they say, well, it comes from this special service, right? So I'm going to model this function. It's an activity, right? It's an input and output. The input to this thing is an email address, a regular old email address, plus some sort of hash or something. And if I give you an email and a verification hash, you're going to give me a verified email, maybe. It's very clear that it might not work because the hash might not match up, right? So sometimes it might not work. Okay, so I get my verified email out of this service. So the final domain looks like this. I have a verified email, I have a verification service, and I have a choice between unverified and verified. And this is, I think, a much clearer design. There's no Boolean anymore. And the rules are actually enforced, because if the rule is, if you have an unverified email, you have to set the Boolean to false, right? Well, we don't have a Boolean. If I have a normal email, the only thing I can do is have the unverified choice. I cannot set the verified choice with a normal email. So I literally can't do the wrong thing. Okay, so I can only set it to be unverified with a normal email address. The only way I can have the verified case, the Boolean is true. The only way I can do that is if I have with this verified email. The only way I can get one of those things is as the output of the service. So that rule about you can only set it if it's been verified, that is now implemented in this way, right? So those business rules are automatically enforced by the design. We don't have to write a unit test for this because it literally can't happen. And certain situations literally cannot even happen. So that's really nice. So that's our final review. Okay, so originally we just had one data structure, and now we have 5 or 6 things, right? But I think this is actually a nicer design because all this stuff, all these questions we had are now in the design. They're not in the documentation, right? So I can see immediately which things are optional. I can see what the constraints are, right? I can see we have these things, email versus verified email. I can see which fields are linked together and which fields are not linked together. And I can see this domain logic about verified and unverified, which wasn't very clear at all with the Boolean flag. Now that we don't have a Boolean flag, this is much easier to understand. So it's more complicated in some ways, but it's also a better design, I think. It's kind of much more self-documenting about what's important, right? And we've got these concepts. And so as we do the design, we actually learn things about the model, like the whole concept of a verified email. We didn't have that in the original design, but that's actually a really useful concept that we didn't know about, right? So there, there's our finished design. Now, this thing about learning as you go along is actually a really important part of the design process, because when you start off, you don't really know very much. And as you kind of model these things, you learn more and more about the design. And we learned about this verified email concept. So it turns out this is useful. Once we have this concept, we can start seeing all sorts of other ways of using the concept. So let's say we have a business rule that we only want to send password resets to people who have verified emails. That's a very good business rule. So we might have this function that sends password resets. Now, if we have a normal email address, we might have to check, is the email address verified or not? If you have the Boolean approach, we have to check whether it's verified. And if it is, we can send the password. If it's not verified, then we have an error saying, well, you shouldn't have called this function. Don't call this if it's not verified. This should never happen. That's always a bad sign when you see code that says this should never happen. And again, if I have a bug and I forget to check the verified flag, that's actually quite a serious bug. So the way to fix this, right, is never to, if you have anything like where you're checking things and you might not make a mistake, don't do this. Model it using this new concept we have. So we now have a new concept called verified email, which we didn't have at the beginning. And now we can say to send a password reset, you have to have a verified email, right? So that's the input to this function. And at this point, I don't have to check the Boolean flag. I don't have a situation where this should never happen, because it literally can't happen. I don't have to run a unit test to check whether it happens or not, because I couldn't even compile the unit test, right? So a lot of things are going to go away. You actually, the coding becomes a lot less defensive. Sometimes you see a lot of defensive programming. Check this, every single parameter is checked. Is this valid? Is this null? Is this blah, blah, blah? If you do this kind of approach, all that defensive programming goes away. You don't need it because it literally can't happen. So just to finish up then, I want to talk about extending this concept even more and more. You can actually apply this. You can start looking for areas where you can apply this idea. And there's a great quote called "Make illegal states unrepresentable" by Yaron Minsky. And what that means is, if there's something that you shouldn't happen, rather than allowing it to happen and then throwing an error or raising an exception, you try and write your code so that it literally cannot happen in the code. And that way you never have to throw an exception, or you never have to document some weird special case, right? Try and write your code where it can just never happen. Now, it can't always, I mean, it doesn't always work, but if you can do it, try it. It's worth a try. So let's look at an example of the design is evolving. And we're just going to add an address, a postal address, as well as an email, okay? So we have a new business rule, which says that we have to have an email or a postal address. So you have to have some way of contacting you, one or the other, right? So if I look at this design, this actually does not meet the requirements, because the way this says, they are both required fields. And they're not both required. You don't have to have both of them. So this does not meet the requirements. So you say, okay, well, I'll make them optional. Now, this doesn't meet the requirements either, because they could both be missing, right? So then you can say, well, I'll just have some validation logic that checks if they're both missing and then throws an exception if they're both missing. No, I'm not going to do it. I want to put it in the design where that situation can't even happen. So how can I guarantee the situation can't happen, right? So let's make the illegal states unrepresentable. The illegal state we're going to get rid of is where they are both missing, okay? So let's think about what the design says. It must have an email or a postal address. So that means there's an email or a postal address or both, right? Notice I'm using the word or, and there are three possibilities with an or. How are we going to model that? We're going to model it as a choice with three possibilities, right? So it's a choice between an email or an address or both, right? Now we've modeled it. The fourth option, where they're both missing, is not one of the choices. We literally cannot have a situation where they are both missing, right? So this design solves that problem completely. So we've actually, implemented the business rule. You cannot make a mistake. In fact, you can't even write unit tests to test the situation, because it literally cannot represent that situation. So this is really cool. And if you can do this kind of thing in your code, it's really nice. So I think these composable types are really, especially the choice types, are almost as awesome. Not quite as awesome as a cat on a unicorn, but pretty awesome. Now, you might be looking at a previous design and saying, actually, that's kind of ugly. I can see what happens when you have more things. You're going to have 9 choices, 16 choices. It's going to get more and more complicated, right? So as a developer, it's okay to push back. It's two-way collaboration. Is a two-way free. We can push back and say to the business, as a developer, I think that's actually ugly. So rather than saying a contact has to have an email or postal address, maybe let's make it a less rigid. How about saying they have to have at least one way of being contacted, which is probably the same thing in practice, not exactly the same thing logically, but from a practical point of view, it's probably the same thing. But this second requirement is much easier to implement in a more flexible way. Because what we can do is we can say, here's the choices for being contacted. I can contact you by email, I can contact you by address. And then my main contact is like a primary way and a secondary way. And the primary way is required and the secondary way is optional. Right now, this is not the same as the first one because I could have 2 emails or something. So it's not exactly the same, but this is probably a lot easier for everyone else to understand. So I think this is probably a better design. And one thing about this is much more flexible when you want to add new things. You can evolve the design. I can add new ways of being contacted very easily without breaking the code, right? So this is, I think this is a nicer design too. So just to finish up then, when we do domain modeling, we want to represent the shared model in code. The shared mental model is in the code. And as part of that, as a developer, you have a responsibility to learn about the domain, I think. So in the card game, I learned about shuffled decks. And in this one, I learned about the concept of a verified email. And it's true, you don't have to become a super expert, but the more you as a developer understand what they're talking, you can use the same language, the experts, it really makes everything much better. And so this collaborative design process is really valuable. And in my experience, spending a couple of days talking about stuff before you start coding is really valuable, right? And you get everything down in the code, and then you can start coding your first prototype or whatever it is. But I just think it's a really useful way of doing things. Now, this is not big design up front, right? This is about evolving the design. So I'm never saying these designs are fixed. As you see, we've evolved the design already a few times. And as you learn things, you can often refactor very nicely as you learn new concepts. But what's nice about using a type system, a statically typed language like this, is as you make a change, you create a new type like verified email or something, that will force you, it gives you the confidence to make a lot of refactoring without breaking the code, because you make a change, your code breaks, you fix up all the compiler errors, and then pretty much your code is confident, you're confident your code's going to be working again. And then from a developer point of view, I highly recommend using a composable type system. I highly recommend using choices instead of inheritance. I highly recommend using options instead of null. Please do avoid primitive types. Please do use types to model constraints like emails and verified emails and other stuff. And also, if you can, try to make illegal states unrepresentable rather than having a lot of runtime checking. So you shouldn't be checking for null. You shouldn't be checking whether your email address is valid in your runtime, most of your code. Once you've created this email address, it's immutable. So once you've validated it and you've got this thing, you never ever have to check it again. You never have to check that it's null. You never have to check that that it's not an email address anymore, that somebody's changed it. So this is my recommended way of doing domain modeling. So that's it for now. I think the slides and video on my website /DDD, and of course I have a whole book all about this. So if you find this interesting, you can read my book. I think we've pretty much run out of time for questions, but I will stick around on the Slack. I will answer questions on Slack, and I also post if you want the PDF for the slides, I will post them on the Slack as well, and you can download them and look at them later on. So thanks very much, everyone. Thanks for listening.